right. Well, thank you for having me here. My name's Chujiao. I'm a principal security engineer from Comcast, and today I'll be talking about bug bounty for third-party open source libraries. So first of all, a show of hand. How many of you have gotten mail that says to whom it may concern, or current residents? Right. And how many have went on to excitedly read it, open it, take action on it? Exactly, same here. So open source security is kind of like that, where most people says like, okay, I'm the user. The owner or the maintainer is responsible for creating it, maintaining it. I just have to update it, or at least like deprecate it if I don't need it, right? Well, not quite true. So open source security concerns everybody because, and it's for good reason because it's everywhere. It helps to prevent vendor lock-in and reduce the total cost of ownership. And it's affordable, it's customizable, it's in over 90% of the code bases. And yet, over 70% of the vulnerabilities are found in indirect dependencies. So why is that? Well, the project maintainer and the owner may know their code very well, but not all of them are security engineers. And so in that case, they don't necessarily have the resources or expertise to do security analysis on their open source projects. And there are initiatives from Open Source Foundation, Linux Foundation, EU, Google, et cetera, to kind of secure the open source landscape, but they focus more on the more popular open source project. And that leaves a gap for open source projects that are used in maybe the company's key product or kind of high visibility applications that are not popular externally. And so to that end, we propose a open source bug bounty. And with the open source bug bounty, you're opening it up to a wider array of researchers with diverse expertise. And it also helps to kind of get more bang for your buck, because now with the amount of based on your resources, you can decide to pay only for the verified exploits and to help kind of secure the open source supply chain. And so to that end, we propose a 4-step bug bounty process. I know there's 5 on there, and that's because tracking is something that should be done regardless of whether or not you're doing a bug bounty. And tracking involves not only what applications is used within the company, but also kind of what libraries are used, how it's used, where it's used, and also whether or not it's updated and such. And then the next step is scoping, because in some cases, the company may have thousands of applications, and each of which uses thousands of open source libraries. And so in that case, well, where do you start? And so you can start by identifying areas of risk and eliminate it down by code characteristic, popularity, et cetera. And then set up by identifying vendors and also pull in the maintainer as well. And then the next step is verification. So to verify the exploits, not only externally, but also internally as how it affects your application. And based on that, negotiate disclosure timeline, and then work with the maintainer and the researchers to check for patches and mitigate externally as well as internally. So first, let's talk about tracking. Open source code usage should be tracked and managed throughout the software lifecycle. And anywhere from when the product is created, when new features are added, when there's CVEs, and when there's need to be updated. And manual tracking is prone to error, incomplete information, and inconsistency. So instead, automating this process with SCA tools can help with keeping a thorough record of the open source library used, as well as timely updates and patch for any vulnerabilities found. And the other question when it comes to tracking is how much information to collect. Because a lot of companies surveyed do not have a good view into the full dependency trees of their software. So it's difficult to identify if a newly discovered vulnerabilities affect their code or not. And one proposed solution is to leverage the software bill of materials. So by having a good idea of the inventory of open source used within the company, we can have a better idea of the focus for the bug bounty initiatives. And the first step of the bug bounty planning is to set the scope, because the company may use thousands of open source in different languages, and it can be overwhelming to figure out where to start. So when we did analysis of open source used by Comcast, we found out that there are a small number of open source used by a large number of applications. And this means by analyzing the top 100 open source used ranked by applications, we cover about 30% of the risk for the different languages. And so from there, we go on to look at the relative popularity, whether it's more popular within Comcast but not popular externally, and then narrow it down by lines of code, last update, license, etc. So the amount of coverage would vary depending on the factors you're using to rank them and also kind of your open source usage. And this is also where it's important to start involving the maintainers, because they're not only needed for patching, but they're also for kind of, you might want to lock the version of the open source library that's being analyzed, and also for them to verify the vulnerabilities and to work with them on the disclosure as well. And next is, how do you want to set this up? So we would recommend platforms instead of doing it yourself, since they have an established process. And they also vet the researchers, and who to choose depend on your scale and budget. And there are a wide array of platforms out there. Some are focusing on open source, and they might be looking at performance and functionality issue as well as security. And some are security focused, but they don't work with open source libraries, so they're not familiar with reaching out to the maintainers. And then there are some people in the cross section. And so who you choose really depends on kind of what you want to get out of the program. And once the bug bounty program is live and vulnerability reports are submitted, the next step is to verify the relevance of the vulnerability. And for this, there need to be a close tie between kind of the internal verification and external verification. Because externally, they could submit a exploit, and it's exploitable outside, but is it relevant to your application? Because you might not be using the kind of the exploit aspect of the open source library, or it might be used in your key application. And so based on the impact internally, you can discuss and figure out, okay, what should be kind of the disclosure timeline? Do you want to negotiate it, even though typically it's 90 days? And then kind of work on the CVs issued and such. And based on that, you can then look at the remediation. And that would depend on the nature of the exploit and type of license used by the open source. So in some case, if the exploit is leveraging existing vulnerabilities, then there might already be patches available, or you might just need to update or tighten the access control. And in some case, if it's a new vulnerability, then there might be new patches in progress from the maintainer or the third-party researchers. And in both cases, it's important to do an internal testing, because you want to make sure that whatever patches that you update is not going to introduce new vulnerability, and it's not going to drastically increase the performance overhead of your application. And in some cases, you might need to create patch internally. And because this is open source code, it's important to check for license. And in some case, if you must open source it according to license, you want to make sure that your patch doesn't include proprietary information. Or in some case, depending on the license, then you may not need to open source it. And then, of course, secure merge back to the repo to complete the cycle. So that wraps up the process of setting up a bug bounty program. And based on the process, we first kind of started testing with setting a bug bounty for JavaScript used within Comcast. And so for tracking, we use Mint to track the number of applications using the different open source libraries. And based on that, we did a risk rank of libraries that are more popular internally than externally. And then from the top 100 of that, we eliminated the ones that has less than 100 lines of code, because if there's only 50 lines of code, there's only so many vulnerabilities you can find there. And also look at the last update, if it's within the last year or if it's in the past couple of years. Because if there's already initiative and activity around a component, then we might want to focus on the ones that are seemingly more inactive. And then also maintainer support, because if the maintainer is unwilling to do security update or patch, then maybe it's time to use an alternative instead of that open source library. And so based on that, we first chose 4 libraries and did a private launch with BugCrowd, which is a security bug bounty platform, for 3 months, and then opened it up to the public. And after that, once the reports come in, we then checked for duplicates and open issues in the reports, and then contact the maintainers and collaborate with them to decide, okay, is this something to accept, reject, or ignore, and figure out the remediation based on kind of discussion between the contributors, internal team, and the maintainers. So from the result of this program, all the submissions were made within the first 6 months. So if you're doing a third-party bug bounty, you don't have to do it indefinitely. Most of the results, actually, the 3 verified submissions were actually submitted within the first 3 months. So if you do it for 3 to 6 months, that gives you a pretty reasonable kind of comprehensive security analysis, or at least like a surface look at the open source library. And even though it's only 4 libraries, it covered 1.1% of risk for JavaScript open source used within Comcast. So we found that the open source community is pretty responsive, and we got pretty good results. Then the next step is to figure out how to scale it, because 1.1% is still pretty small. And if we're just doing 1% at a time, we're going to do it for eternity. And so the next step is, all right, let's look at kind of concentration of risk or usage, where we realize that for kind of the top 100 open source library used within Comcast, when ranked by the number of applications, it covers only about 30% for JavaScript, but it covers about 85 to 90% for Python and Java. So we just end up starting with kind of the one with the lowest coverage. And then so of course, like, well, let's move to a higher coverage. So we decided to go with Python for the second round for kind of, more to optimize the risk coverage for the amount of resources we're devoting to it. And the top 100 open source library use doesn't change much from year to year. And so this is a case where the more you do, the less you have to do in the future. And from there, we then kind of reach out to Hunter platform, which is focusing on open source security bug bounty, to kind of help with the legwork of reaching out with open source maintainers. Because that's where we realize it's like, okay, instead of commercial code, this is a little different because we need to contact the maintainers, and to get their buy-in, we also need to reach out to open source researchers. There's also license, there's also disclosure, and you had to do this for each individual open source, and that's just not practical. And so Hunter, in this case, when I reach out, they actually have 81 of the top 100 Python libraries already onboarded. And then so they have established process working with the open source community, and they have security researchers. And so that allows us to focus more on kind of figuring out what are the open source that are more critical to Comcast, and to identify and kind of expedite the internal remediation instead of on the legwork with the open source community. So with all of those, we have learned quite a few things. So one, it is vital to keep track of open source usage within the organization, because the amount of open source is only going to increase and not decrease. And as time goes on, it's going to get harder and harder to figure out what's in it, who's using it, and whether or not there's updates, there's patch, is it safe? And there's tools that you can use, but once it gets to, if your open source usage is increasing exponentially, it's hard to catch up. And so it would be good to kind of introduce good open source hygiene from the get-go, from the development lifecycle in the beginning. And the second is, securing open source is different from securing commercial code, because you need to involve the open source community. And also, there is no standard. In order to put out open source code, they don't need to satisfy any security criteria. They don't need to do any security analysis. Anybody can put out open source code. And so the onus is then on the user to figure out, okay, is this secure or not? And also, even when there's an exploit externally, that doesn't necessarily mean you're compromised internally. You may not be using that component of the code, or you might be using an in-key product, and then the question becomes, who patches it? In some cases, the maintainer might patch it, or the researcher might patch it, and then the vulnerability is already out there. Or if your team decide to patch it, well, if the open source library is used by about 500 teams, then who do you pick to patch? And so really, you need to work with and not independent of open source community, because the maintainer may need to be involved for patching the vulnerabilities and also the question of disclosure. So by keeping good track of what open source are being used where, and taking a proactive approach to security analysis of open source, the company can mitigate the hidden risk before they're realized. And a bug bounty program is a cost-effective way to leverage the security research community when the individual product team or maintainer may not have the bandwidth or the expertise. So I'll wrap it up there, but you can keep it open and keep it secure at the same time. And if you're interested in kind of detail for any component of the presentation, they are in the 2 paper listed. I'm old school, so I didn't put a QR code on there. But the hidden risk of unpopularity, that's something that can help you to figure out, all right, if you're using millions of open source library, how can you narrow it down to kind of the concentration of risk? And you can look at different component of security, of popularity, of kind of code characteristic. And then there's also kind of the bug bounty detail in the second paper as well. Now we're up there. Question? Mm-hmm.
Did you take any decisions that Comcast needed to be involved in the upstreams regularly, or is this simply when you find security holes? Because it sounds like there's not a full, two-way street going on.
Right. So that is actually the purpose of the initiative that we've been running, because I joined Comcast about 5 years ago, and then so the JavaScript thing was started about like 4 years ago, and then the second round with Python was started about 2 years ago, but it only wrapped up this year. And so this is an attempt to kind of move the security of open source to the left, where instead of focusing on incident response when Heartbleed came out, when Log4j came out, we're looking at the hidden risk of open source of what we use. And then there's disclosure because at some point, we're really buying time with a third-party bug bounty. And after the 90 days, then it is released with like the CVEs and such. And within Comcast, we also have like a nice OSPO program to kind of advertise about open source, as well as kind of a small group of people who enjoy contributing to the open source. So I've roped them in as well in case the maintainers can't do a patch, then internally we can contribute to the open source in kind of like a more targeted manner. Any question?
Just continuing with that, look like you've been doing it for some time.
Mm-hmm.
More interested in how you convince Comcast to have a budget and to make it public. So then you are also telling people who are interested in these CVEs, right?
Oh, that is the fun stuff. Because even though I said I've been working on it for 4 years, there was 1 year where it was just pure paperwork. And so, yeah, because open source, it's different from commercial because, they don't own the code. And then they're also not buying the patches because it needs to be open source. And then so I want 2 kind of argument I made. One is that, you do not want another Log4j if you can prevent it. And then second is that, this is a way for us to secure it. And then you may not be buying the code, but you're really buying time. And then you're helping to secure kind of the open source landscape, which in turn might come back to you because you might have visibility only into one level of dependency, but you might be using something you don't even know like 2 or 3 levels back. And then if a lot of people do it, there's like open source initiative externally. And if you do it, like the more you do right now, the less you had to do later, as you can kind of see in that statistic. Then it's like, it's not something that you have to be intense about like for the rest of your life. It's like, no, it's like the more you do now, like maybe after 2 or 3 years, you would be able to secure a large portion of Comcast, let's just say. And so it's like, okay, we have been producing good results so far. And so that's why we do kind of like 3-month pilots, 6-month pilot. This way we have kind of periodic results to show for Comcast, be like, this is what you paid for. Therefore, you should give us more money to do more of this. Yeah. Question?
What was the most difficult part of this bug bounty program?
The most difficult. I mean, there was definitely a lot of lesson learned because initially when starting this, we definitely didn't realize there's so much legwork involved with reaching out to maintainers because I came from security. This is my first foray into open source. So I didn't realize like, oh, there are some projects where you have multiple maintainers who are responsive. There are some projects where you have no maintainers, and some project where the maintainer is just like, I just don't feel like doing anything with this. I don't want to do security stuff. And so it's definitely a lot of collaboration, a lot of legwork, and I learned a lot about the open source community. So the intersection of security and open source is where it's a little bit tricky, because security is already a sensitive topic. And then now they want you to open it up. So it's just like, whoa, whoa, whoa. So, yeah. Any other questions? Sounds good. So thank you for having me. And I'm happy to talk about open source bug bounty if anybody else have some thoughts later.